Hi, welcome. In this video, we will be discussing about limiting reagent. This limiting reagent is another important aspect that is generally studied in mole concept. Now, when it comes to definition, we have the definition of limiting reagent, the reactant that gets over first and limits the reaction. So generally when we say chemical reaction, there can be one reactant, there can be two reactant, or there can be more than two reactants also, depending upon the nature of the reaction. So at least one reagent will be there which is acting as a reactant. Now when there is only one reactant, there is no concept of limiting reagent, because that reaction will stop only when that particular reactant, which is only one reactant, gets over. Now suppose a reaction has more than one reactant, say two reactants are there, A and B. Suppose we have two reactants A and B. Now they are giving rise to product C, suppose. Now the product formation depends upon quantity of both. Now in case one of the reactant is present in lesser quantity than the stoichiometric requirement, for example, now according to this equation, 1 mole of Al and 1 mole of, not Al, the A, 1 mole of A, 1 mole of B combine to give 1 mole of C. Now suppose instead of taking 1 mole, I take only 0.5 mole. Then what happens is that the reaction is limited by reactant A. So we may not get the quantity of C as expected. That means the quantity of C obtained will not be same as the quantity predicted by the stoichiometry here. So let us understand this by taking a small example. So here are few pictures. So there is a seat here, handle, this is a chassis and wheels, and here is a bicycle. Suppose we want to assemble bicycle. So our target is to assemble bicycles. Suppose we are given say 50 seats, then 100 handles, then 50 chassis and 80 wheels. So we have 80 wheels, 50 chassis, 100 handles and 50 seats. Imagine we have been given this much. Now we start assembling. So we all know one cycle requires one chassis, one handle, one seat and two wheels to make a normal cycle, of course. Now we start assembling. So if we look at the quantities given here, we have 50 seats. That means we can, according to, if we see only the seats, there can be 50 bicycles formed. We have 100 handles which are not needed actually, because only 50 seats are there. So we need only 50 handles, 50 will be extra. 50 chassis are there and we have 80 wheels. Now you see each cycle requires 2 wheels. So 80 wheels means 80 by 2, that will be only 40 cycles assembled. So at last we are able to identify that wheels limit the number of cycles we assemble. So 80 wheels means I can only assemble 40 cycles. So though there are so many excess of seats, too much excess of handle and excess of chassis, I am not able to make 50 cycles or 100 cycles, because there is only limited wheels. So exactly same phenomena occurs in chemical reaction also. If the reactants taken are not according to the stoichiometric ratios. So I just took example of a general reaction A, B and C. So more detailed uh, version we will see now. Suppose we have 2A plus 3B giving rise to 2C. So A, B, C are hypothetical reactants and products, and this is a reaction. So considering the stoichiometric coefficients like this, so it's very clear the stoichiometric coefficient is 2 here, 3 here and 2 here. Suppose we are given, so each question generally gives the composition of the reactants. So whatever quantity they give, we should convert that to moles actually. So here we are discussing the strategy, how exactly we solve the question based on limiting reagent. Now generally it can be of 2 reactant or 3 reactant. Generally for JEE mains and NEET, even JEE advanced, generally they do not ask more than 3 reactant. So I have taken 2 reactant here. Nevertheless, the method remains same for even 3 reactants. So considering 2 reactants here, now according to stoichiometry it says that 2 moles of A and 3 moles of B combined to give 2 moles of C. Now suppose among A and B any one is less than the stoichiometric ratio, then what happens? That becomes the limiting reagent, because of which we will not be able to get as much product as predicted by the balanced chemical equation. Of course, while solving this type of questions, we require balanced chemical equation. Suppose given number of moles are, say, here 4 and here also 4. Now next thing what we do is, obviously number of moles of reactant they will not be giving in, that we will have to calculate. Now what we calculate is ratio of mole to stoichiometric coefficient. So that will be 4 by 2. So this is what we are calculating. So I will change the color. 4 by 2. This will be uh, this will be 4 by 3. Now if we calculate these values, this will be 2 here and this will be 0.75. Now our target is to identify the minimum uh, ratio. So whichever has minimum ratio, say, so this is minimum ratio. So when I calculate ratio like this, whichever has minimum ratio, that will be limiting reagent. So it's very clear that uh, this B is limiting reagent. So it is LR. So once we identify limiting reagent, this limiting reagent is one which is going to govern the reaction now. So all our calculation has to be based on limiting reagent. Now we know according to stoichiometry, number of moles of A divided by 2, because 2 is the stoichiometric coefficient, is equal to number of moles of B divided by 3, because 3 is stoichiometric coefficient here, is equal to number of moles of C by 2. So this we know according to stoichiometry. Now we know number of moles of B given is 4, and this is going to limit the reaction. So in that case, number of moles of C formed is equal to 2 into, because this denominator, now I am just equating these two, I am just equating these two, I'm just equating these two. So number of moles of C formed is equal to 2 will go to the numerator here. Number of moles of B. Number of moles of B is 4 because that is the given, divided by this is the 3 here. So this is number of moles of B. So I can easily calculate in general by 3 because our B is the limiting reagent. Similarly, number of moles of A reacted. So A reacted is equal to, so again from this equality I should be calculating it as 3 into not 3 into, it should be 2 into, because the denominator here is 2. So 2 into NB by 3. So in this way we can easily calculate the number of moles of A reacted. So this will be the shortcut techniques. Of course, mole concept we can always apply. That is based on the linear calculation. So let us take one question based on this concept. I hope it's very simple and it's very clear here. So we basically have to calculate the ratio of number of moles given to stoichiometric coefficient. That will give us another number, which is actually the ratio of number of moles to stoichiometric coefficient. So whichever is smaller, that will be the limiting reagent. Now among these two reactant, B will be the limiting reagent because it has more stoichiometric coefficient and less number of moles of reactant as expected. So that becomes the limiting reagent. Now obviously excess reagent, so every reaction, if it has a limiting reagent, will have a excess reagent too. So I can say excess reagent will be A, which is equal to maybe number of moles of A left out. That means some quantity of A will remain unreacted. That will be equal to initial number of moles, that is 4 moles here, minus number of moles of A reacted, which can be already I have shown how it is calculated here. So we can substitute that and calculate excess reagent. So let me take one sample question here. So this is the question. If 10 gram of H2 and 96 gram of O2 are allowed to react in a closed container, what will be quantity of water formed? So basically it's closed container, so we have to write the balanced chemical reaction. Product or reactant is not lost to the surrounding, so balanced chemical reaction is the first requirement. Balanced chemical equation is H2 plus O2 giving rise to 2H2O. Okay, it should be 2H2 here. So that means stoichiometric coefficients are 2, 1 and 2 here. Next thing is they have given 10 gram of H2. Now in our discussion we had taken number of moles. So immediately we will have to write number of moles of H2 is equal to 10 by 2. So we calculate number of moles and then use, because directly using mass may be simple, but again it can cause confusion or it can be mistake also when we do it in hurry. So best is to convert it to number of moles and then calculate. Similarly, number of moles of O2 given is equal to 96 divided by 32. So this will be I can say this is 3 moles. So number of moles of suppose, so this is given moles given. So here we have 5 moles of H2 and 3 moles of O2. So ratio of stoichiometric moles to stoichiometric coefficient is 2 by 5. This is 5 by 2, and this will be 3 by 1. Now if you look at the uh, smallest ratio is nothing but 5 by 2. So this is LR. This is a very simple first. So limiting reagent is H2. So first answer is limiting reagent. They are actually asking us what will be the quantity of water formed. So we cannot say directly that 5 moles of H2 is there. So 2 moles of H2 gives rise to 2 moles of H2O. 5 moles should also give 5 moles of water. So that will be a wrong answer. Of course, when you have an objective type of multiple choice questions, one of the options will surely be this, that is 10 moles, sorry 5 moles, but that will not be the correct answer. So now as per our technique, we have already decided that this is a limiting reagent. So next thing is to calculate quantity of water found. So from mole concept we have number of moles of H2O by 2 is equal to number of moles of H2 divided by 2. So this is our uh, equation obtained based on the stoichiometric coefficients. So basically number of moles of H2 given is 5 divided by 2. So number of moles of H2 is equal to 5 moles. Of course, coincidentally here we are getting 5 moles of water, which is because H2 itself is the limiting reagent. Otherwise, directly applying mole concept, like you can say linear calculation that 2 moles of H2 gives rise to 2 moles of H2O, will turn out to be wrong. In this particular question, fortunately H2 is only the limiting reagent, so it will be 5 moles only. Suppose our calculation, if we do it based on oxygen, say 3 moles are given, so 3 moles of O2 should give rise to 6 moles of H2O, we may end up in wrong answer. So that will also be one option. So if we mark 5 moles, surely it will be correct answer. So weight, if they, yeah, quantity of water formed, in case if they ask weight of the water formed, it will be 5 into 18 grams. So it will be 90 grams. Okay. So in this way we will have to calculate the answer for this type of questions. So one more type of question is asked. So let me take that as the last question in this topic. So here is the question. 5 moles of SO2 and 5 moles of O2 are reacted to form SO3 in contacts process for preparation of sulfuric acid. Of course, this is an information. Find excess reagent mass of SO3 formed. So first thing is we write balanced chemical equation, that is SO2 plus O2 giving rise to SO3. So for balancing we need 2 SO2 here. So again stoichiometric coefficients are 2, 1 and 2. Every time we may not have to write like this, immediately we can go ahead with our calculations. So moles given are 5 here, and here also 5 moles. Then excess reagent, yeah. Now next thing what we do is that ratio, which is like 5 by 2 here. Here it will be 5 by 1. This will be 2 by 2. Of course this is not given, we have to calculate this. Now out of these two, again SO2 is the limiting reagent, so LR is very simple to find out. Whichever is smaller in uh, magnitude, that will be the limiting reagent. once we find limiting reagent, our calculation should be based on number of moles of SO2. For example, here number of moles of SO2 by 2 is equal to number of moles of O2 is equal to number of moles of SO3 by 2. This is according to the stoichiometry of the reaction. Now I cannot consider these two and calculate the number of moles of SO3, because there is always a chance that we are given this number of moles of O2 and we can directly calculate SO3 through this. That is true only if both the reactants are limiting reagent. That means there is no one particular limiting reagent. That means there will not be excess reagent also. So in such reaction which are stoichiometrically perfect in nature, we don't have to decide limiting reagent and then calculate based on that only. But in this type of reactions where limiting reagent is involved, we have to calculate like this only. So number of moles of, so I can write limiting reagent is SO2. So calculation of product formed has to be based on number of moles of SO2 only. This is the important aspect to keep in mind. So next what we do is number of moles of SO3 formed is equal to number of moles of SO2 reacted. That will be 5 by 2 moles. Sorry, 5 moles. It's actually total. Whatever is used, whatever is given will react. So total 5 moles of SO2 will react. 5 moles of SO2 will react. That means how many moles of they have asked mass of SO3 formed. So WSO3 is equal to 5 into 80 grams per mole, because 80 is the molar mass of SO3. So 400 gram of SO3 is formed. Along with, they have also asked to find excess reagent. Obviously oxygen is the excess reagent. So let me scroll down. Yeah, so excess reagent is equal to O2. Now number of moles of O2 left out is equal to number of moles of O2 given minus number of moles of O2 reacted. So O2 given is 5 moles minus reacted is again easy to calculate, number of moles of O2 reacted, which is actually 5 minus, here if we see number of moles of O2 is number of moles of SO2 by 2. So again we don't consider SO3. Of course now we have calculated number of moles of SO3 formed, so we can always use. But if we have not yet calculated the quantity of sulfur trioxide formed here, we should always consider the calculation with the limiting reagent here. So it's very simple. Reacted is number of moles of SO2 divided by 2. It will be 5 minus 2.5 is equal to 2.5 moles. So suppose we calculate weight of O2 left out will be 32 into 2.5. That's 80 grams. So our answer is 80 gram here and 400 gram here. So this is one answer which we have got. This is another answer. So like this we will be solving limiting reagent questions very easily. So thank you for now. We will come up with many other videos like this. If you have any doubts or comments, please do put it in the comment below. Thank you.